Okay, so now we're sort of moving back a little bit to the sort of modelling that Eve told us about during the keynote. Although it is a different model, and we'll be emphasising more the role that reef fish play in those sort of systems, and particularly in terms of their predation on Crown-of-Thorns starfish. So I just want to acknowledge the traditional owners, and in particular, because I'm based in Hobart, the Muwina people were the traditional owners of the land that I work on. So this is a CSIP project, and the objective really was to look at evaluating the efficacy of fish conservation strategies in controlling Crown-of-Thorns starfish outbreaks, and therefore what benefit that might bring to corals and thus the entire community. And as I mentioned, we're using for this another reef meta-community model to explore scenarios. So the underlying idea of what we're trying to do here is this idea that certain reef fish prey on Crown-of-Thorns starfish, either in their juvenile or adult phase, and therefore that if they're preying on the Crown-of-Thorns, then that's going to reduce the predation pressure on corals, and therefore obviously improve the state of the reef. And we're focusing mainly on two types of reef fish here: the emperors, things like spangled emperor and red-throated emperor, which are known to prey on Crown-of-Thorns starfish, and also gropers like coral trout, who don't prey directly on Crown-of-Thorns, but there's an interaction there through the food web. And you can see if we're changing the level of fishing and thus the populations of these predatory fish species, then that's ultimately going to impact on Crown-of-Thorns and corals themselves. Okay, so the model we're using for this is known as the Coral Community Network model, or CoCoNet. This model's been around for a while now, and probably some of you are familiar with it. It's somewhat similar to what Eve talked about with their reef model, but there's also, I guess, almost purposeful differences. So the structure of the model is different in various ways, and we try to maintain those differences to give us, so that we're sort of better capturing the uncertainty when we're applying kind of a multi-model ensemble to different problems. And so, similar to reef mod, it contains multiple coral groups. There's 6 coral groups that vary from fast-growing sort of acropora type things through to massive corals. We also have an age-structured CoTS population preying on the corals, and one difference from reef mod is that we have these age-structured fish populations, which are explicitly represented. And on top of all that, we have the environmental impacts such as cyclones and marine heat waves, which are obviously impacting the corals. And we also have the human activities. So this might be control of Crown-of-Thorns starfish, or line fishing, which is obviously reducing the fish in the system. And we can also explore, various other interventions in the model. And because it's a meta-community model, so we're representing all these individual reefs down at the scale of the CoTS control sites. So that's sort of like a 10-hectare type scale. But all the reefs are interacting through spawning events of coral, of Crown-of-Thorns starfish, and of the predatory fish. And you'll hear more about the sort of connectivity aspects in talks later in this session. So the sorts of interventions that we're trying to model here range from modifying the zoning. So as you probably know, on the Great Barrier Reef we have green zones and blue zones, where the fishing is not allowed on the green zones, and so we can vary how many reefs and which reefs are zoned in certain ways. We can just look at fisheries management strategies such as reducing catches. We can impose size limits on the fish catches. So at both ends, we could protect the larger fish or protect small fish. Getting a little bit more speculative, we can stock, restock reefs with some of these predatory fish. That's not happening at the moment, and it's probably pretty challenging, but it's kind of interesting to look at in the modelling sense. And of course, the control program itself, we can also model. And there's other talks that are going to be detailing that more as we go forward. The way we run the model is we essentially we actually started in around 1900, and we have this kind of 70-year equilibration period. So you just it doesn't really matter how you initialise, but all the reefs are initialised with the various populations, and then we allow quite a long period for this whole system to come into equilibrium, and then we model a historical period, through to present day essentially, and this is also the period over which we calibrate this model based mainly on LTMP data, that's long-term monitoring program data, and then once we have that calibration in place, the models then run out over a projection period, which goes up to, can go in anything you like really, but out to 2075, and that's quite a long projection. But you've got to remember that underlying this, we've got the time frame for CoTS outbreaks is like 15, 16 year frequency. So we want to get multiple CoTS outbreaks within our projection period. And this whole thing then is run on a large ensemble, because there's all this uncertainty in these models and lots of stochasticity. So we run it over and over again, in this case 30 times, to sort of get a handle on how much variability there is in the model. And if we look at an example of the output, now this is a kind of interesting case where we say, well, what's the difference between what's happened historically in terms of imposing, the management regime in terms of our zoning and our management of fisheries? What's that look like relative to if we'd done nothing, if we just let things play out? And as you can see here in these plots, these are essentially showing quartiles over time, going from around 2000 to 2075. There's obviously a large benefit to fish, and consequently the number of outbreaks drops quite substantially. You can see again there's plenty of uncertainty there, but there is those trends, and then there's a net benefit to coral cover as well, and a substantial area of coral has been gained through those interventions. So it's sort of confirming that was a very worthwhile process. Now, if we look at some of our other scenarios, the black line at the bottom there, so this is the percentage point change in CoTS outbreaks, and the plot, the black line at the bottom there is the one I just showed you. So the difference between historical versus if we'd done nothing, and you can see there's a very substantial change in that case. These percentage points, remember, they're not just a percentage increase. So if we get a drop by 4 percentage points, that's and the percentage of outbreaks at any time is only 10%, then that's sort of like a 40% improvement in the situation. And you can see, it's pretty much what comes out of this is quite hard to change it substantially beyond what we've already achieved. Stock replenishment for emperors is substantial there, but as I said before, that's really quite difficult to do. And now if we look at the subsequent change in coral cover from the same set of scenarios, again, what we've done previously has been, a huge benefit. 2%, 2 percentage point increase in coral cover, but if we had 20% coral cover initially, then that's still a 10% increase in total coral cover. So, that's very worthwhile. And there's some other things that, it's quite variable over time. But if you look out, at later on, in the later part of the time period, then what comes out is that probably things like CoTS control are still our best bet going forward. So just a point on, so why is it difficult to make these additional gains? Partly it's because CoTS account for less than half coral mortality, so there's a lot of other things going on in the system around, cyclones and bleaching and so on. And the other thing is that the nature of the outbreak, we can implement things and change the nature of the outbreaks, but we don't necessarily always have a big gain in coral cover, because we might be going from, pushing the system from acute outbreaks into more sort of a chronic level of CoTS over the system. So just conclusions. So the rezoning that's already happened and the fisheries regulation has clearly, at least according to the model, significantly enhanced the health of the GBR. We have marginal benefits from further expansion of zoning or reductions in fishing, so we're into that sort of diminishing returns. CoTS control may provide more reliable gains over the longer term, and we're going to hear more about that in some of the future talks. And just something to keep in mind, all these runs were conducted under essentially the Paris target sort of scenarios. And as Eve mentioned, that they're probably a little bit optimistic, so we chose those because we wanted to see the signal from changing fisheries management, etc. But, it might be even harder if the climate scenario looks worse. Thanks.
Thanks, Scott. It's great to see the sort of progression of this work. It's been going for a while. It's awesome. Your penultimate slide, you actually talked about the acute versus chronic kind of outbreak pattern. Certainly something we've had lots of discussions about. I mean, partly from a management point of view, it may be easier to manage a chronic pressure for a whole variety of reasons than an acute one. Yep. I just want to know whether you've actually been able to model that as to what the kind of impact profile actually is when you've got this chronic ongoing pressure, as opposed to these sort of peaks or booms and busts in the CoTS outbreak cycle.
Yeah, well, the way the model works, we don't actually impose that. That's just an emergent property of the model, and we've seen, evidence suggests that is what the model suggests does happen, sort of thing. So I think you're right that if there's other things in the model like CoTS control, then they are more effective at dealing with that just on a capacity basis, because if it all happens at once, you can't. It's hard to do much with. I guess the only context that we've looked at so far is it just emerges out of the model and it is what it is, kind of thing. But it's an interesting part of the problem, and I think probably in other systems, I think even Japan and things, they've seen this sort of effect where you do move from a more acute to chronic impact. So something to keep in mind when we're trying to manage these things, for sure.
One more quick one. Well, it's not that quick. I guess I'm just curious. I've been a bit cautious with both this model and reef mod. I've been thinking for quite a while that the big thing that drives all the trajectories and whether or not a certain strategy is going to be effective is how sensitive it is to bleaching mortality, really. And the thing I've sort of come to realise is that it's all based off the one bleaching assessment that we have is at quite shallow depths. And I'm a bit concerned that we're being potentially a bit over-pessimistic. I'm just wondering if you've got any ways to account for it, because there's been a few, like the 22 and 2020 bleaching, both like totally understandably why they were over, like the mortality was overestimated, and the one going on now probably be a different story. But it just concerns me a little bit then we're running it out so far, and without updated mortality assessments, we're potentially going to be throwing away ideas that might offer benefit. So that's not really a question, it's just a thing that's been on my mind for 2 to 3 years.
No, fair enough. And I mean, that, as I said, that's the exact logic why we chose Paris and not maybe what Eve talked about as the most likely scenario. Because there is this, bleaching is one thing, but what is the ultimate bleaching mortality is a huge source of uncertainty in these models. And I noticed it even in the modelling where we try to reproduce the recovery that we've seen in coral over the period that we've also seemed to have had the most bleaching events, so from 2017 onward. That's actually, the model sometimes struggles with that just because the recovery is so fast when all this bleaching is supposed to be happening. It's telling us that uncertainty is really important. And what our strategy is to try to not over-emphasise that. Yeah,
that's a very fine line because you don't want to
signal,
underrepresent it as well.
So we can't see anything else.